guys? So today we're moving on into the last lesson of Unit 13, which is 13.4, and we're going to be looking at quadrilaterals on the coordinate grid. So basically what's going to happen is you're going to have a quadrilateral or a polygon that is going to be on a coordinate grid, and you're going to have to look at the sides and the angles of the lines and determine what type of polygon that shape is, determining the different pieces of the puzzle that you're looking at. So let's go ahead and jump into that. So we're going to be using the slopes of lines. We're going to be using possibly the midpoint of a line and possibly looking at the different slopes of those. So the thing you guys need to realize is whenever you have two slopes, if two slopes are parallel, they have the same slope. If two slopes are perpendicular, they have opposite reciprocal slopes. Meaning I'm going to take the slope, I'm going to flip it and change the sign. So we're going to be analyzing those pieces of information. And then also your distance formula. If I want to find the measurement between 2 points, I'm going to end up using the distance formula, okay? So let's go ahead and jump into our examples. We're going to be using some of these to help determine what type of polygon it is. All right, so right now, example number 1, it says to determine the quadrilateral on the grid by using the properties of the polygon and its diagonals. So the first thing I want to look at is I want to look at the slopes of those, because the thing is whenever we did 13.2, whenever we were looking at all the properties of quadrilaterals, we were looking at if they're parallel or not. And so that deals with the slope of the line. So I need to find the slope of each one of these points here, okay? So right now let's look at this line here. And I can do that by using the slope formula, or I can just count over and up, just like I always do, rise over run. So right now I'm gonna go over 1 and I'm gonna go up 1, 2, 3, 4, 5, 6. So that would be 6 over 1, which is just gonna be a slope of 6. So that means right now, this is going to be 6 right here. Okay, so now I'm going to look at the line opposite of that. So I'm going to go over 1, then up 1, 2, 3, 4, 5, 6. So if you look, that has a slope of 6. So right now that means this line is parallel to this one. Okay, so let's go and look at the other lines here. So starting at this point, I'm going to go over 1, 2, 3, 4, 5, and down 1, 2, 3. So that means the slope of this line is going to be rise over run. So I'm going down 3 and over 5. So that means this is going to be down 3 over 5, so -3/5, okay? Now I'm gonna look at this one down here. So I'm going down 1, 2, 3, 1, 2, 3, 4, 5. So again, I'm going down 3 and over 5. So that means the slope of this line is -3 over 5. So right now what you can see is that opposite sides are gonna be parallel to each other. So right now this is basically a parallelogram, okay? And the one thing to notice here is that this slope and this slope adjacent to each other are not opposite reciprocals, meaning if I flipped 6 over 1 and made it negative, those aren't opposite reciprocals. So what that tells me is that this is not perpendicular, it's not a 90-degree angle. So it's not a rectangle or it's not a square, okay? So, but I do know this is technically a parallelogram. So now what I need to do is I need to compare their lengths. So these are all the slopes. I know that opposite sides are parallel to each other. Now I need to look at their distance, meaning their measurement here. So let's go ahead and look at that real quick. Okay, so let's go ahead and find the distance of this line here, okay? So right now it looks like I'm at point over 2, so going from here. So I'm just gonna make a right triangle, right? So I'm gonna go over 1, then I'm gonna go up 1, 2, 3, 4, 5, 6. So right now, over 1, up 6. So I'm gonna do 1 squared plus 6 squared, and then I'm gonna take the square root of that to find my C value, correct? Okay, so I'm gonna take the square root of that. So 1 times 1 is 1, 6 times 6 is 36. 1 plus 36 is gonna be 37, so I'm gonna do the square root of 37, which is gonna give you the length of that line. So this line right here is actually going to be the square root of 37. Well, just so you know, I'm going over 1 and up 6 on this one as well. So that's going to be the same thing. So I'm doing the square root of 37 here. So those sides are congruent. So now I'm going to check the other ones here. Okay. So now on the other side, I'm going over 1, 2, 3, 4, 5, and I'm going down 1, 2, 3. So that's a 5 and a 3 triangle. So that means I'm going to do 5 squared plus 3 squared, and I'm going to take the square root of that. So 5 times 5 is 25. 3 times 3 is 9. 25 plus 9 is going to give me 34. So that's going to be the square root of 34 on top. So this guy right here is going to be the square root of 34. So now I know that this is down 3 and over 5 too, so this is going to be square root of 34. So if you look, all the sides are not congruent, so that means it's not a rhombus, but opposite sides are congruent as well. So this double clarifies that this is indeed a parallelogram, because in a parallelogram, opposite sides are congruent and opposite sides are parallel. So ladies and gentlemen, this is indeed going to be a parallelogram, because I compared the slopes of the lines to see if they're parallel, and then I also looked at the distance formula to show that those are going to be equal to each other, okay? Let's jump over to example number 2. All right, so on example number 2, it wants me to plot the points, and then it wants me to, what would be the point for D to make a parallelogram for A, B, C, and D. So right now, A, I'm gonna plot 6, 2. So I'm gonna go over 1, 2, 3, 4, 5, 6, and up 2. So that would be point A right there. Point B would be -1, 2. So I'm gonna go over 1 and up 2, okay? And then C would be -4, -5. So I'm gonna go over 4, 1, 2, 3, 4, 5, and then down 5. 1, 2, 3, 4, 5, okay? Okay, so right now we need to kind of get the picture here. So if I wanted to make a quadrilateral out of this, my point is gonna be somewhere down here, because I'm gonna have to end up putting the point here in order to do that. But now remember, a parallelogram means that the opposite sides are parallel to each other, okay? So what that means is they're basically gonna share the same slope on opposite sides. So literally what I could do is I could count the slope up and over to here, and then I could count the same slope from this point going down and over to get the same point here. So I'm gonna go and do that. So using a different color so we can see it, I'm gonna count over. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So I'm going up to 7, so that would be down 7 and left 4. So from this point, I'm gonna go down 7. 1, 2, 3, 4, 5, 6, 7, and over 4. 1, 2, 3, 4. So ladies and gentlemen, it looks like my point would fall right here, and that would end up making it a parallelogram, indeed. Okay, because now those would share the slopes. If I actually drew my line here, let's go ahead and draw it. So if I drew my lines here and made it as best I could, I know that I did the same slope. So these two have the same slope, so they're parallel. And then these two actually have the same slope as well because they're horizontal lines. So ladies and gentlemen, this would end up making a parallelogram. So my answer would be +2, 1, 2, 3, 4, 5. So +2 and -5 would be the coordinate that I would put. So that would actually end up being the coordinate of D. So again, they shared the same slope, so they're parallel. And then also, I'm going over 4 and up 7. So if I use Pythagorean theorem, over 4, up 7, it would still be the same distance if I ended up using those. And the distance between these are the same. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So they're same distance, okay? So ladies and gentlemen, again, on your skill check, you're going to be taking this information and you're going to be comparing the slopes of both sides and the distances of both sides. So you're going to be using these formulas to try and determine what shapes you're actually given on the coordinate grid. If you guys need help, please call me over. I'm here to help, okay? Good luck.